Hi, I'm Mike Marin, and in this video we're going to discuss implementing a bootstrap approach for building a confidence interval with R to compare a numeric variable for two different groups. This can be thought of as an alternative approach to building a confidence interval for the difference in means using large sample approaches. In separate videos, we explain the concept and general approach behind building this confidence interval. We also show how to conduct a bootstrap hypothesis test on this exact same data. You can ask R to calculate the median weight only for those on the casein feed type, as well as the median. You can find links to all these videos in the video description below. You can also find links to the R script and the data used there as well. It's highly recommended that you watch some of those videos before watching this one. Now, let's import the data and remind ourselves of the data and context a little bit. Let's quickly add this data to the data view in case we want to look at it that way. And we can remind ourselves this data set has two variables, weight as well as feed type. So it's looking at weight gain of chicks on one of two different feed types, casein or meat meal. And we can also see this data set has 23 observations in total, 12 chicks on the casein feed type, 11 on meat meal. In order to explore the weight of these two different feed types, we can make side-by-side box plots here. Now, in the previous video when discussing confidence intervals, we decided we'd build a confidence interval for two different estimates. The first estimate being the difference in means of the two groups, and the second estimate being the difference in medians of the two groups. At the end of this R script, we also provide code for building a confidence interval for the difference in the 80th percentile of the weight gain for the two different feed types. Now let's have R calculate each of these two estimates. First, we can look at having R calculate the mean for each of the feed types. Here we can ask R to calculate the mean weight only for those whose feed is casein, and the mean weight only for those whose feed is meat meal. And as always, I try to include some different, slightly more sophisticated ways of doing things in R. So you can explore the following code and see how we can make use of the with command as well as a tapply statement to end up producing the exact same thing. Now let's calculate the sample or the observed difference in means, and let's store them in an object called obsDiffInMeans. So we can do that here, and taking a look at it, we can see the difference is 46.67. So the mean weight for casein on average was about 46.7 grams higher than it was for meat meal. And again, a fancier way of doing that, making use of the diff or difference command, a with, and a tapply statement. Now we can quickly have R do the same for the observed or the sample difference in medians. So again, here's calculating the median for each group. We can do that with a with command. And let's calculate the difference in medians. And we'll store this in obsDiffInMedians. And again, here we can see that the sample difference in medians was 79. In other words, the median weight for casein was 79 grams higher than it was for meat meal. Now, let's start discussing implementing a bootstrap approach to building a confidence interval for each of these estimates. It's worth mentioning that R does have packages built for doing bootstrapping. You can see one of them here, the boot package. So you can take a look at that on your own if you want, but I prefer to show you how to build it yourself rather than rely on a package which may or may not be easy to work with. I always prefer to build some of these things from principles myself. So when building this confidence interval, the first thing I'm going to do is I'm going to set a seed. Okay, this isn't completely necessary, but the reason that I do this is so that I can get the exact same set of bootstrap resamples anytime I run this code. Then the NC here is the number of casein observations to resample for each bootstrap sample. Recall that we had 12 observations for casein diet or feed type. NM is the number of meat meal observations to resample, again for each of the bootstrap samples. And B is the number of bootstrap samples that we'd like to take. So here we'll take 100,000 bootstrap resamples. And it's worth recalling that increasing B, or the number of bootstrap samples, does not increase the amount of information in our data. Now, because a confidence interval uses the observed or the sample estimate as the point of reference, we're going to sample with replacement from casein and from meat meal separately. So to do this, first we'll produce a matrix of casein bootstrap resamples. We're going to take B equals 100,000 bootstrap samples, each of size NC 12. So in other words, we're going to ask R to resample with replacement from the observed casein measurements and to take B times NC, or 100,000 times 12 observations. We'll have this stored in a matrix called boot.casein, where each column of the matrix is a bootstrap resample. So let's go ahead and have R do that for us here. We can see that was done pretty quickly. Now we can ask R to do the exact same, but for the meat meal group. Now it's a good idea to check and make sure that R did what we thought it did. So first we can check the dimensions of each of those matrices to make sure that looks right. We can see there are 12 rows by 100,000 columns, or 11 rows by 100,000 columns. So that looks good so far. The dimensions look right. Now let's also check just the first 5 rows and first 5 columns of each, just to make sure that they've been populated with data and they're not sitting there empty. So again, we can see here's the casein bootstrap samples and the meat meal. And so it looks good. Looks like R's done what we hoped it was doing. Now, let's calculate the bootstrap estimates of the difference in means. Here, I'm going to make use of the colMeans command to calculate the mean of the columns. You'll recall that each column is a bootstrap sample. So I'm going to ask R to calculate the mean for casein in each bootstrap sample, and then subtract from that the mean of meat meal in each bootstrap sample. And we're going to store all of this in bootdiff_in_means. So let's submit that and have R do that here. And again, let's quickly check that to make sure R's done what we thought it has. We can see this bootdiff_in_means consists of 100,000 elements, which is what we would hope. And taking a look at the first 10 difference in means, we can see here's the first 10 bootstrap estimates of the difference in means. Now we can do the same for estimate number 2, the difference in medians. Here we want to calculate the median of each column, right, of the bootstrap samples. And to do so, I'm going to make use of an apply statement, and I'm going to apply the median function to columns, which is indicated by margin equals 2 argument. So let's submit that here. Okay, and again, it's good just to check to make sure that R did what we thought it did. We can see this bootdiff_in_medians consists of 100,000 elements or estimates. Here's the first 10 bootstrap estimates of the difference in medians. So now let's get to building those confidence intervals. So the first thing to mention is there are slightly different approaches to building a confidence interval using a bootstrap approach. The most commonly used approaches are the percentile method, the basic method, the normal method, and the bias corrected method. In this video, we'll focus on implementing the percentile method as it's the most intuitive, and we're going to leave it to you to read a bit more about the others if you'd like. The percentile method takes the entire set of bootstrap estimates, and in order to form a 95% confidence interval, the 2.5 percentile of all the bootstrap estimates or bootstrap distribution is used as the lower bound for the interval, and the 97.5 percentile of the bootstrap estimates is used as the upper bound. In other words, the range of the middle 95% of bootstrap estimates is used to form the 95% confidence interval. So let's have R calculate the 2.5 percentile as well as the 97.5 percentile of the bootstrap estimates first for the difference in means. Here we can use the quantile command, right, and asking R for the bootstrap difference in means, find the 2.5 percentile. And now we can ask it to find the 97.5 percentile. So here we'd say that we're 95% confident the true or population difference in means is somewhere between about -4 up to positive 96.8. Or using casein as our reference diet, we can phrase that as we're 95% confident that the mean weight for casein is somewhere between about 4 grams lower than meat meal up to 96.8 grams higher than meat meal. Similarly, we can construct the 95% confidence interval for the difference in medians using the percentile method. So let's do that here. Again, we're going to ask R for the 2.5 percentile of all the bootstrap difference in medians, as well as the 97.5 percentile for the bootstrap difference in medians. Here, we can say that we're 95% confident that the median weight for casein is somewhere between about 24.5 grams lower up to 116 grams higher than meat meal. Now, taking note that both of these intervals contain 0, from this we can deduce that the means or the medians are not statistically significantly different. It's worth recalling that throughout all of our videos, we regularly remind ourselves of the difference between statistical significance and scientific significance. While these differences do not appear to be statistically significant, there is evidence that the feed types may differ. So you'll recall that we only had 23 total observations, 12 casein and 11 meat meal. And I'd say looking at this data definitely warrants further investigation. Now in the R script, we've included some extra code to construct confidence intervals using the basic method for a confidence interval, as well as some code for confidence intervals where the estimate is the difference in the 80th percentile of weight for each of the feed type. So you can feel free to explore these on your own if you like.
Subscribe to our channel, share our videos. Stick around guys, because we got lots more. Thanks for watching our video. I want you to have a nice time.